Greetings to everyone. Today I would like us to look at indices. Now, a number is said to be written in index form if it is of the form, let's say a raised to the power x equal to y. This a, the a is called the base. This b is called the power or index or exponent. So if you have a number of this form, for example 2 raised to the power 3, of the form 2 raised to the power 3, it is in index form. This 2 is the base and this 3 is the power or index or exponent. And when working with indices, there are some laws that will ease our work. And to do that, we should always verify when multiplying, to use as a shorthand form, we always verify the basis of the numbers that are in index form, because a number in index form is a condensed form of a number. Look at the base here. The base is a, the base is a, and we are multiplying. What do? We add the powers. If the bases are the same when dividing, what we do is we subtract the powers. Now we equally have other laws, such as a raised to the power negative n is equal to 1 divided by a raised to the power n. We have a raised to the power m order n is a raised to the power m times n. Then we have any number raised to the power 0 giving us 1. We equally have a raised to the power a fraction. When it is raised to a fraction, you see here the denominator. The denominator here is representing the root, and the m here is representing the power. So we say a raised to the power m over n is the nth root of a all that to the power m. Now if you have a times b all that to a certain power, it will be a raised to the power n times b raised to the power n. If you have a raised to the power 1 over n, is the nth root of a. And if you have a over b ordered to the power n, it will be a raised to the power n divided by b raised to the power n. So those are the laws of indices which can be used in solving the equations that are in index form. Okay, we have exercises here. 25 raised to the power negative half. Now, knowing that 25 raised to the power negative half, it means you have a number of the form a raised to the power negative n. So you will use the law 1 over a raised to the power n. This negative half means it will be 1 over 25 raised to the power half. And when you have 25 raised to the power half, the denominator here is 2. So it will be square root of 25, which is 5. Now, if you have 16 raised to the power 1/4, it means the fourth root of 64. It will be the fourth root of 64. And if you have 3 raised to the power 5, all that to the power 2, it will give us, you see, you multiply here, you will multiply the powers. The power here is 2 and here 5. So 5 times 2 will give us 10. 3 raised to the power 10. And if here is 3, 1 over 3, for example, it will instead be the cube root. So when you see the denominator there, it will be the cube root here. Here will instead be 3. And if it was here, instead of 1 over 3, is 2 over 3. If there were 2 here, it will be cube root all that square. So that's it. So cube root of 64 here, it will be 4. If it was 2 over 3, it will be 4 now squared. Now we have some more examples here. Solve the following equations. We have index equations here. We're going to see how to approach index equations. 1, we have 2 raised to the power x equal to 32. 2, 4 raised to the power x over y equal to 0.25. 0.25. Now, whenever we are asked to solve an index equation or exponential, we make sure that the bases are the same. Like in the first case here, 2x equal to 32, we have to see how to write 32, right, in terms of base 2. So 32 can be written as 2 raised to the power 5. And the bases are the same, 2, 2, so the powers will be the same. If the bases are the same, for them to be the same index, because when you're talking about indices, we are looking at the base and we are looking at the power. So if you have already written the number in index form and the bases are the same, we can conclude that the powers must be the same when we are solving that. So x equal to 5. Now here, we have 4 raised to the power x plus 1 is equal to 0.25. 0.25 is 1 over 4, which is 4 raised to the power negative 1. You see, we have been able to write it now. The base here is 4, the base here 4. And since they have the same basis, therefore, for them to be equal, since they say equal means the powers must be the same. X plus 1 equal to negative 1, which implies x equal to negative 2. Okay, let's look at the third example. (25 raised to the power x minus 6 into 5 raised to the power x plus 5 equal to 0. Okay, now, indices. This is a type of index equation which will lead to a quadratic form. We have here 25. The base here is 5 raised to the power. The base is 5 here, then the power is x. 25 raised to the power x. How can it be written in terms of 5 raised to the power x? That's the first thing to note. 25 on its own can be written as 25 on its own is written as 5 square. And 5 raised to the power 2x. Remember, we just did the laws of indices, the power. A raised to the power m times n. A raised to the power m, all that n is a raised to the power m times n. And multiplication is commutative. For us to make sure that these powers have the same variable, it will be 5 raised to the power x is all that to the power 2. This is to make sure that this term inside is the same. The term here is the same as this one here. So rewriting it now, we have 5 raised to the power x, all that squared, right? You see, it will now be a quadratic equation in the form with term here 5 raised to the power x. With variable 5 raised to the power x, as you can see here. 5 raised to the power x. This one now is the constant term. This 5 is the constant term. So to solve this quadratic now, this is a quadratic equation. And if we have to solve it, we can reduce it. We say let t be 5 raised to the power x. So we give us another equation. We now have t squared minus 6t plus 5. Okay, but remember, you said let t be equal to 5 raised to the power x. So when you do it as such, you have t squared minus 6t. Now, if you have to factorize, factorization here, our a is 1, our c is 5. 1 times 5, it gives us 5. Which two factors of 5 will you multiply to give negative? Will you add to give negative 6 and multiply to give 5? It's negative 1, negative 5. You write it in this form. And you arrive here, t is equal to 5, t is equal to 1. But when you are at that stage, you have not still solved that equation completely. That's why we say, but t is 5 raised to the power x. And we have here 5 raised to the power x. It means the main variable that we are solving for, we go to 5. And 5 means 5 raised to the power 1. Right? And since the bases are the same, 5, 5, the powers now must be the same, which makes us to have our x equal to 1. And also 5 raised to the power x is 1. 1 is 5 raised to the power 0. Because any number raised to the power 0 gives us 1. So x equals to 0. That's the solution. Now, can as well decide to use method 2. That is, since we have seen that it is a quadratic equation in terms of 5 raised to the power x, we use our quadratic formula, negative b. Our b here is negative 6, plus or minus b squared, negative 6 squared, minus 4a, a is 1, c is 5, divided by 2a. And when this is expanded, we have 5 raised to the power x is 5 raised to the power is 6 plus or minus square root of 16. 5 raised to the power x is 6 plus or minus 4 divided by 2. So we have 6 plus 4 divided by 2, 5. And we know 5 raised to the power x is equal to 5. 5 means 5 raised to the power 1. The power will give us x. Likewise this one. So you can equally use a quadratic formula to do all of that. So that's what it takes to solve index equations or exponential equations of that nature. Okay, thank you for watching. Please do not forget to like, share, subscribe, and hit the notification button for more videos. Thank you. Have a great time.